This is the edge of the universe. Well, not really, but this might be the closest thing we have to an edge of the universe. At least for now, this is the cosmic horizon. And if you were to sail out into space forever, you would eventually hit this horizon, and then you wouldn't be able to see anything beyond it. And you probably wouldn't want to stay there anyway, but more on that later. The idea of a cosmic horizon seems pretty straightforward, but it's also a little weird. So let's try to wrap our minds around it. This video comes with a quiz that lets you check how much you remember. You may have heard that we can only observe a part of the universe, the so-called observable universe. This is because we can only see as far as light has had time to travel since the Big Bang. Put another way, we can only see objects if they are within 46.5 billion light years of Earth. That distance is called the cosmic horizon or the particle horizon. To understand why it's like that, consider what it takes for an object to become visible to us. Light from very distant objects takes a long time to reach Earth. Even light from relatively close galactic neighbors takes thousands of years to get here. The most distant objects we've seen so far are the galaxies from about 13.7 billion light years away. These galaxies existed in the early days of the universe just 400 million years after the Big Bang, so even though the universe is vastly bigger than this, we can't see what lies outside the cosmic horizon, not yet anyway. If you wanted to visit these far-off places, you'd have to break the cosmic speed limit. In other words, travel faster than light. As cool as that would be, we currently don't know how to do that. There are two main reasons why we can't see farther than the cosmic horizon. The first reason is that the universe is expanding. Distant galaxies are receding from us and their light gets stretched, shifting them towards longer and invisible wavelengths. This effect, known as the Doppler shift, makes the distant galaxies invisible to us. It's the same reason why an ambulance siren sounds lower-pitched as it drives away from you, but there's more to the story. The second reason is that the cosmic horizon is always moving. Let's go back to those distant galaxies. They are receding from us, and the light from those galaxies is getting stretched to longer wavelengths. However, space itself is also stretching. The fabric of space-time is being pulled apart as the universe expands. As space stretches, it does so unevenly, and the amount by which space stretches depends on how far away it is from you. Space near you doesn't stretch as much as space far away from you. As a result, the distance between you and the receding galaxies increases faster than the distance that light could cover. Eventually, the recession velocity of the galaxies overwhelms the ability of their light to reach us, and those galaxies fall beyond the cosmic horizon. It's kind of like when you're stuck in traffic, and even though you aren't necessarily driving faster than normal, you still end up further away from your destination than expected. And just like that, things can get weird. In some ways, it almost feels like the cosmic horizon is chasing us. It moves along with us, always keeping a safe distance, except the distance is 46.5 billion light years. And yes, the cosmic horizon does move with you. No matter where you go in the universe, you will always be able to see 46.5 billion light years. But just because the horizon keeps moving with us doesn't mean we won't eventually catch up to it. As absurd as it might sound, that actually will happen. In about 200 billion years, the speed of the expansion of the universe will flip and our cosmic horizon will start shrinking. At that point, we will begin seeing previously invisible parts of the universe that used to lie beyond our cosmic horizon. But don't get too excited. Just because we will be able to see farther doesn't mean we'll be able to explore those places. We'll still need a way to travel faster than light. We have no idea whether that'll be possible. But maybe by then we lines have figured out something that will allow us to get closer to the edge of the universe than any of our ancestors ever dreamed of. Or maybe we'll figure out that there isn't an edge to the universe. Some astronomers think that the universe is infinite. That means that it extends endlessly in all directions. If the universe is infinite, then it doesn't have an edge. And if it doesn't have an edge, then you can never really sail out into space and reach it. You could sail for an infinite amount of time, but you would always find yourself at the center of an infinite universe. Other astronomers believe that our universe is flat. While flat universes can be infinite, they can also be finite. A finite flat universe is kind of like the surface of a balloon. No matter which direction you travel on the surface of a balloon, you will never reach an edge. But if you travel far enough in one direction, you will eventually come back to where you started. In a flat, finite universe, you might travel for billions of years until you suddenly find yourself smack dab in the middle of the Big Bang, a hot, dense soup of particles. It's not entirely clear what would happen if you tried to pass through the Big Bang, but it's probably not healthy. But perhaps the most intriguing possibility is that the universe is hyperbolic. A hyperbolic universe is saddle-shaped. If you sail straight ahead in one direction, you will eventually hit an edge. But if you turn around and sail in the opposite direction, you will end up exactly where you started. All these different shapes for the universe raise an interesting question. If we can never reach the edge of the universe, how can we know what shape it is? To answer that, astronomers use something called the cosmic microwave background. This is the leftover radiation from the Big Bang, which fills the entire universe. By measuring tiny temperature variations in the cosmic microwave background, astronomers have been able to map out the shape of the universe. Their conclusion: the universe is flat to a very high degree of accuracy. But even though we have mapped out the shape of the universe, we still don't know if it is infinite or finite. And if it is finite, we don't know what's on the other side of the hyperbolic edge. In a sense, this means that we don't know what's at the edge of the universe. Of course, we can't actually see the edge anyway, but it's fun to speculate about. If you were to sail out there, you wouldn't find just empty space. You would find more galaxies. In fact, you would find more galaxies than you left behind. That's because as the universe expands, new galaxies pop into existence out of seemingly nothing. They emerge because space itself is stretching, not just where galaxies already exist, but everywhere. New galaxies form in places that used to be empty. So, if you sailed past the edge of the universe, you would immediately encounter brand new galaxies that didn't even exist before you left. In other words, you would be exploring uncharted territory. Maybe you would even find planets suitable for life. Maybe there is a planet out there with people who are looking at their version of the cosmic horizon and wondering what lies beyond their cosmic horizon. Of course, you wouldn't be able to tell them because you would be in uncharted territory. You would be completely alone, and you would want to stay away from the edge of the universe for another reason. The edge of the universe is a dangerous place. As you approach it, the gravitational pull from the newly forming galaxies becomes extremely strong. You would get stretched like taffy until you were as thin as a sheet of paper. And if you managed to survive that, you would be utterly crushed by the gravitational forces of the galaxies. So even if you could travel faster than light, you would probably want to avoid the edge of the universe. Still, it's fun to think about what might be on the other side of the cosmic horizon. Maybe there's a whole other universe over there that we just can't see. Maybe everything we know about physics would be different over there. Maybe the laws of nature would be different. Maybe there would be different constants. For example, the gravitational constant, g, determines the strength of gravity. The value of g in our universe is very finely tuned. If it were even slightly different, stars wouldn't form, planets wouldn't form, and life as we know it would be impossible. Yet over there, g could be different and life might be possible, or maybe the speed of light, c, could be different over there, or the mass of an electron, or any of the other fundamental constants of nature. If the constants were different, the laws of nature would be different, and physics would be more difficult. Luckily, we don't need to worry about that because there is no other universe. The edge of the universe is just more of the same. But still, it's fun to speculate about what might lie beyond the cosmic horizon. Maybe we'll find out sooner than we think. After all, the cosmic horizon is always moving. It's moving outward at 91 kilometers per second. That's 327,000 kilometers per hour. So if you want to get closer to the edge of the universe, all you have to do is sit back and relax and watch the horizon move closer and closer until one day soon it hits you right in the face. Thanks for watching.